This video is on 17, Congruence and CPCTC. First of all, what is congruence? Congruence in geometric figures are figures with exactly the same size and exactly the same shape. In terms of triangles, we can have a formal definition that two triangles are congruent if and only if. Now, if and only if is once again a biconditional statement, meaning that it goes forwards and backwards. So two triangles are congruent if and only if their corresponding sides and corresponding angles are also congruent. So in terms of a visual representation, we can say that triangle ABC is congruent to triangle JKL if and only if all of the corresponding sides and angles are congruent. In this diagram, what that means is angle A has to be congruent to angle J. Angle J. Angle B must be congruent to angle K. Angle B must be congruent to angle K. And angle C must be congruent to angle L. Angle C must be congruent to angle L. Additionally, all of the sides must also be congruent. So AB must be congruent to JK. AB must be congruent to JK. BC must be congruent to KL. BC must be congruent to KL. And lastly, AC should be congruent to JL. AC congruent to JL. Now, the reason I'm able to name all of these in succession order is because this congruency statement that we see here, this congruency statement, gives us the order of the vertices. And the order of the vertices is the same in each triangle. It tells us which parts match up with which parts, which sides match up with which sides, which angles match up with which angles. It's very, very important that we go in the correct order, as we'll see in this next example. If I give you a diagram and ask you to state all the congruent corresponding sides and angles, in this diagram, I give you tick marks to kind of help us with this. So we would see, we'll start with the angles first. Angle B has one tick mark. Angle B would be congruent to angle W in my other triangle because it also has one tick mark. Angle D has two tick marks. That's congruent to angle V. And lastly, angle C is congruent to angle U. Make that V a little pointier. Now, in terms of sides, we can do the same thing. BD has one tick mark. BD is congruent to side VW. Two tick marks. DC is congruent to two tick marks VU. And BC is congruent to WU. Now, for the overall congruency statement, I'm going to start in the first triangle. I like to go in the order of the tick marks that I've made. So BDC, triangle BDC, is congruent to, now in my other triangle, we're going to follow the same order. So 1 to 2 to 3. So WVU. Now, the order that you chose doesn't actually matter as long as you're consistent in both triangles. That's important as we take a look at example 2, where if I don't give the diagram but still ask for all the congruency statements, we'll start with the angles because that's the easiest to start with. The first letter in this triangle is M, which stands for angle M. So angle M matches up with the first letter in my second triangle, which is angle R. And then so we can continue on with angle P is congruent to angle D, second letter to second letter. And angle T is congruent to angle F, third letter to third letter. Now, with the sides, we are going to go ahead and match up two sets of letters. So side MP is congruent to side RD. We can match up the last two letters, PT and DF. PT is congruent to DF. It's matching up the vertices there. And then finally, we did 1 and 2, 2 and 3. The only other combination we have is 1 and 3. So MT is congruent to RF, 1 and 3. The most direct application of writing the congruency statement and stating all the corresponding sides and angles that are congruent can be found on this idea of corresponding parts of congruent triangles are congruent, which is abbreviated CPCTC. So the definition of congruent triangles is in fact a biconditional statement, which means that it's conditional and the converse are both true. So if we can show the corresponding parts of two triangles are congruent, then the entire triangle is also congruent. These are modeled after SOL questions. So given two triangles, I want to find the values of X and Y that show that the two triangles, triangle RQP and triangle IJH, are congruent. So from this congruency statement, I can start matching up corresponding sides and corresponding angles. We'll start with angle Q. We have an angle measure of 96 for angle Q. From the congruency statement, I know that it is congruent to angle J. So I know angle Q is congruent to angle J, which is this angle over here. Well, by substituting in their values, I know that 96 is equal to 42 plus 9y. Well, this is just an algebra problem that we can go ahead and solve. Subtract 42 from both sides gives me 54 is equal to 9y. So therefore, y is equal to a value of 6. Now, same idea. We can go ahead and figure out side lengths. I see that RP has a value of 7, R and P. I know that is congruent to side length IH in my second triangle, IH, based on the congruency statement. So I can set up the equation 7 is equal to 5x minus 13. Adding 13 to both sides gives me 20 equals 5x. So therefore, x is equal to 4. Okay. Another example of this, find the value of x that makes the two triangles congruent. So if I would like to have the two triangles be congruent, that means all the sides and angles should match up in each. If we notice in this diagram, all of the side lengths have some expression involving x. Now again, x is consistent throughout the entire problem, so as long as I solve x in one of the relationships, it should be true for all of them. So I'm going to start off with just looking at side DE in my first triangle, which is this side 3x plus 1. So DE, I would like it to be, or I'd like to know that it's congruent to side length MN, which is this side. Simplifying this now, after substitution, 3x plus 1 is equal to 31 minus 7x. I can go ahead and solve for x here. Add 7 over, 10x plus 1 equals 31. Subtract 1, 10x equals 30, giving me x is equal to 3. Now once again, I could set up a relationship between the other sides. I should still get the same x value. Just to show you, if I set up EF and NL, EF congruent to NL, so EF congruent to NL, that is the relationship of 23 minus 3x equals 2x plus 8. That also solves to give us that x is equal to 3. And lastly, I could also set up the relationship of DE and ML. DE congruent to ML. In this case, 7x minus 9. 7x minus 9 equal to 3x plus 3. Solving this also gives us x equals 3. Regardless of which relationship we set up, we still find the same value of x. The important part here is that we're using our congruency statement. We're using our congruency statement to set up a relationship between the corresponding sides or corresponding angles. The last problem I want to talk about is directly above this. This is an SOL style question asking about triangle congruence on a coordinate plane. What we need to do here is I want to figure out what triangle is congruent to this red triangle I'm highlighting, but they gave it to us as ordered pairs. So I'm going to quickly go ahead and graph these. Now that I have these 4 triangles graphed, green, blue, black, and gray, just by simply inspection, I should note that triangle C, the black triangle, looks to be congruent. Now, if I wanted to verify this with previously learned formulas to help us, we remember if I'm given a right triangle, so if I'm given a right triangle, we could use the Pythagorean theorem. Pythagorean theorem, which states that a squared plus b squared equals c squared, where c squared is in fact, c is the hypotenuse. The other more useful one, for instance, if we don't have a right triangle, which is in the practice example, we could use the distance formula to find the length of each side of the triangle using the endpoint vertices as my x and y values, x and y values. Remember, the distance formula is equal to the square root of x minus x squared plus y minus y squared, where we're using two different x values and two different y values as we're going through. Okay, this will show up in the SOL style question. Please give the practice on the other page a try. We will go over this in class.